Okay, this question has some things about solubility. It says barium carbonate is insoluble and it is a precipitate when solutions of soluble compounds, barium chloride, sodium carbonate, are mixed. And then when solutions, it actually tells you everything here. Look, when solutions of soluble compounds, potassium chloride and sodium sulfate, are mixed, no precipitate is formed. So barium chloride, it tells you barium carbonate is made. Barium sulfate is what we're trying to decide. So sodium chloride, hopefully I already know, is definitely soluble. Barium sulfate is insoluble. It is our test for sulfate ions. So I would get a precipitate barium sulfate. Usually if a carbonate is insoluble, the sulfate will be insoluble as well for that particular metal. Potassium chloride and sodium carbonate, well, nothing's going to happen there because I'm mixing sodium and potassium. So all I'm doing is swapping always soluble for always soluble. No precipitate. Ugh. That's why there's no precipitate here. Sodium, potassium, nothing happens. Like you can't swap a sodium for potassium and get a precipitate because all sodium compounds are soluble, all potassium. Okay, this time, sodium sulfate, calcium chloride. So I'll make sodium chloride, well that is soluble. But then the other thing I'll make is calcium sulfate. And as we said up here, we assume if a carbonate is insoluble, so is the sulfate. So I'm going to say precipitate. Carbonate and sulfate are very similar ions, big -2 charge. They tend to do the same thing. The same way that chloride, bromide and iodide also have the same trends in solubility. Okay, solutions. Oh look, fantastic. It's another precipitation reaction and a precipitate of lead 2 bromide. So straight away I'm going to put an S next to my lead bromide. There it is. Everything else, solutions of lead 2 nitrate, solution of potassium bromide, AQ. You can't make 2 solids, job done. On the other side, we then want to talk about how to make a pure dry salts. So this time they've told you what to do, filter, wash, dry, but they want to know a bit more detail. So why do they filter it? To remove the solid from solution or something along those lines, to separate the precipitate would be another way of putting it. Something like that. Why did he wash? To remove the other ions from the solution. The ones that were soluble, they would stay on there if you left the solution on there. Why is it better to use distilled water? And that again, let's be really specific and not just say it might be contaminated, but to say that tap water contains ions. And then why he left it in a warm place is just to dry the crystals. Same as what we had before.